Hello, welcome to Learning Theater. In today's video, we're going to talk about what we call the Krebs cycle. Krebs cycle. This is also known as the tricarboxylic acid cycle. The tricarboxylic acid cycle, or the citric acid cycle. Yes. So this was developed by Hans Krebs. So we have done this glycolysis pathway, and we all know that we converted glucose to two pyruvate molecules, and then we generated two net ATPs and 4 NADH. We said that whenever there is oxygen, we take the pyruvate into the mitochondria and then transition it into the Krebs cycle. And so in the transition step, we add a coenzyme A to this reaction, and when we do that, we generate two carbon dioxide molecules and then two NADH by a decarboxylation. So in today's video, we're going to look at what we call the Krebs cycle. So we have this one here, 6 carbon molecule. That is our glucose molecule, and with that one we were able to produce pyruvate molecule. So pyruvate molecule is a 3 carbon molecules, and when pyruvate gets into the mitochondria, it gets converted to what we call acetyl-CoA. So let me name them. This is acetyl-CoA. This is pyruvate. And this is glucose. So this acetyl-CoA that was made through the transition step, and it will then fuse with a molecule, 4 carbon molecule known as oxaloacetate, to form a new molecule known as citrate. So this is acetyl-CoA. It will fuse with this molecule known as oxaloacetate. And then it will form a new molecule which is known as citrate. And then this citrate is a 6 carbon molecule. So this is our citrate here. Citrate, a 6 carbon molecule. And then this is going to be catalyzed by an enzyme known as citrate synthase. So that's the name of the enzyme, citrate synthase. And this enzyme is highly regulated. It is very highly regulated. When we are making a lot of ATPs, that will inhibit this enzyme, because we are already having too much of ATPs. So when we are making too much ATP, it will inhibit this enzyme. So this enzyme is very, very highly regulated. So the first one that can inhibit this enzyme is too much ATP will inhibit this enzyme. And also a lot of NADH will also inhibit this enzyme. So a lot of NADH will inhibit this enzyme. And also citrate is supposed to be converted to isocitrate and not build up. So when you are making too much citrate but it's not being converted to isocitrate, that will also inhibit this enzyme. So citrate itself can also inhibit this enzyme. And also what is known as succinyl-CoA can also inhibit this enzyme, because to prevent it from making more of him, so it will inhibit this enzyme so that it will not make too much succinyl-CoA. So succinyl-CoA will also inhibit this enzyme, succinyl-CoA. And also the next thing that can also inhibit this enzyme is more ADP. Definitely more ADP means low ATP. So when we are making more ADP, means we have low ATP, and that will stimulate this enzyme to make more ATPs. So more ADP will also inhibit this enzyme. Now, so by this enzyme citrate synthase, acetyl-CoA and oxaloacetate will fuse together and then form a 6-carbon molecule known as citrate. This is citrate here. An enzyme known as aconitase will come and then convert this citrate to a new molecule known as isocitrate. The enzyme is called aconitase. So let me do that. Aconitase. This enzyme will convert citrate to a new molecule known as isocitrate. So isocitrate. This isocitrate has the same number of carbons with citrate. They all have 6 carbons, just that it undergoes isomerization reaction. So isocitrate undergoes isomerization reaction, and that is reshuffling of the hydrogen atoms. So it undergoes isomerization, and when it does that, it reshuffles the positions or the locations of the hydrogen atoms, but it has the same number of carbons and then hydrogens, just that the positions of the hydrogens differ. And there is a chemical known as fluoroacetate that is found in rat poison, and it is only this chemical that can inhibit this enzyme. And when it inhibits this enzyme cannot convert to isocitrate. So the chemical known as fluoroacetate, it is the only chemical that can inhibit this aconitase enzyme. And when it inhibits aconitase enzyme, it prevents citrate to be converted to isocitrate. And an enzyme known as isocitrate dehydrogenase will convert isocitrate into a new molecule known as alpha ketoglutarate. So this molecule is known as alpha ketoglutarate. Alpha ketoglutarate. And the name of this enzyme is called isocitrate dehydrogenase. So isocitrate citrate dehydrogenase. This enzyme will convert isocitrates to alpha ketoglutarate. Yeah, and this step is irreversible. This step is irreversible. From isocitrate to alpha ketoglutarate is an irreversible step, and alpha ketoglutarate is a 5-carbon molecule. 5-carbon molecule, meaning we lost a carbon in the form of carbon dioxide. That is a decarboxylation. We lost a carbon in the form of carbon dioxide, a decarboxylation. So, meaning we lost a carbon in the form of carbon dioxide. And also, NAD plus was converted to NADH. NAD plus is converted NAD plus is converted to NADH. Yeah. And this enzyme has 3 binding sites. This isocitrate dehydrogenase has 3 binding sites, and too much ATP will stimulate this enzyme. So this enzyme can be stimulated by too much ATP. Too much ATP will stimulate this enzyme. So let me do that one here. Let me do that one. Too much ATP will stimulate this enzyme. And also too much ATP will inhibit this enzyme. Too much ATP will inhibit this enzyme from making more ATPs. And then too much ADP will stimulate this enzyme to make more ATP. So too much ADP will stimulate this enzyme. And also calcium ions can also stimulate this enzyme. Calcium ions can also stimulate this enzyme. Yeah. And this calcium will act as a signaling molecule in the muscles, and it is needed in order for muscle contraction. Yes. And from there, this alpha ketoglutarate, an enzyme known as alpha ketoglutarate dehydrogenase. Alpha ketoglutarate dehydrogenase. Let me write it. Alpha ketoglutarate dehydrogenase. Alpha ketoglutarate dehydrogenase enzyme. This enzyme will convert alpha ketoglutarate to a new molecule known as succinyl-CoA. Succinyl-CoA. Yeah. It will convert alpha ketoglutarate to a new molecule known as succinyl-CoA. This succinyl-CoA is a 4-carbon molecule. This succinyl-CoA is a 4-carbon molecule, and meaning that we lost 1 carbon again. And then when we lost a carbon in the form of carbon dioxide, so we lost a carbon in the form of carbon dioxide. And anytime we talk about dehydrogenase, it also means that we are converting NAD plus to NADH. NAD plus to NADH. Yeah. And remember, the name acetyl-CoA is succinyl-CoA, sorry. The name succinyl-CoA means that we added a CoA group here too. So, in the conversion of alpha ketoglutarate to succinyl-CoA, we lost a carbon in the form of carbon dioxide. NAD plus was converted to NADH, and also we added a CoA group. So let's do that one here. So we lost a carbon dioxide and also NAD plus. Okay, NAD plus was converted to NADH, and we added a CoA group. Yes. So to form a new molecule, a 4-carbon molecule known as succinyl-CoA. And also, in doing this, we form this succinyl-CoA, which is a 4-carbon molecule. Yes. And this enzyme, alpha ketoglutarate dehydrogenase enzyme, can be inhibited by succinyl-CoA. It can be inhibited by succinyl-CoA. When there is too much succinyl-CoA, it can inhibit this process to avoid making too much of it. Yes, so this enzyme can be inhibited by succinyl-CoA. So let me do that. So it can be inhibited by succinyl-CoA. And also too much NADH also result as a result of too much NADH as a result of converting too much alpha ketoglutarate to succinyl-CoA can also inhibit this enzyme. So when you are making too much NADH, that one can also inhibit this enzyme. So too much NADH can inhibit this enzyme. And also calcium ions can stimulate this enzyme. Calcium ions will stimulate this enzyme in order to speed up the ATP production. So calcium ions will come and then stimulate this enzyme to speed up the ATP production. So calcium ions. Yeah. Now, what happened next is that after we form this succinyl-CoA group or CoA molecule, succinyl-CoA molecule, the CoA will be removed. The CoA is going to be removed. Yes, so let me do that here. We're going to remove the CoA. So CoA, remove it. And when we remove this CoA, we generate energy. And this energy is going to use this energy, our body use this energy to take ADP and inorganic phosphate and then form what we call GTP. Yeah, so our body uses this energy that we generate when we remove this CoA group and then add inorganic phosphate and form GTP. Yeah, so let me do that one. So that energy plus that energy is in the form of GDP plus inorganic phosphate will form what we call GTP. Yes. And GDP takes the phosphate from, when it forms the GTP, GDP will come and then take the phosphate from GTP to form ATP. Yes. So when it does that, So when GDP plus inorganic phosphate convert to GTP, ADP will come and take the phosphate from GTP and make ATP. And when that happens, GTP will go back to its original state, that is GDP. So look at what is going to happen. So inorganic phosphate plus GDP. GDP is the energy we got when we remove the CoA group. So this inorganic phosphate plus this GDP will convert to GTP, and ADP will come from nowhere and then take the phosphate. You have guanosine triphosphate. When we take one phosphate from it, it's going to be guanosine diphosphate. So we're going to take one phosphate and give it to ADP, adenosine diphosphate, to make it adenosine triphosphate. And when we make that, it is going to remain with guanosine diphosphate. That's the original GDP. Yes, so this is what is going to happen. ADP from nowhere will come and then take the phosphate from GTP and then form ATP. When it does that, this GDP will go back to its original GDP. It will go back to its original GDP. Yes. And then an enzyme known as succinyl-CoA synthase will then convert succinyl-CoA to succinate molecule, a molecule known as succinate. And that molecule is also a 4-carbon molecule. So succinyl-CoA synthase enzyme will convert succinyl-CoA to a new molecule known as succinate. So the enzyme is called succinyl-CoA synthase. It's synthesis, not synthesis. Synthesis. Yes, this is the name of the enzyme. It will convert it to a new molecule known as synthase. Succinate, sorry. Succinate. Yeah. And with this succinate, an enzyme known as succinate dehydrogenase will also come in and convert this succinate to another 4-carbon molecule known as fumarate. Fumarate, yes, fumarate. So this is the fumarate. Fumarate. And the enzyme that does this conversion or catalyzes this reaction is known as succinate dehydrogenase. Succinate dehydrogenase. Yeah. That is going to convert this enzyme, this molecule, succinate molecule, to a new molecule known as fumarate. And this, in doing this, we will convert FAD plus to FADH2. We will convert FAD to FADH2. FAD will be converted to FADH2. Yeah. And remember that this step is a reversible step. Yeah, this step is a reversible step. After we form fumarate, an enzyme known as fumarase will come and then convert fumarase to a molecule known as malate. So the enzyme is called fumarase. It will convert this fumarate to malate. Yeah, so this is also called malate. It is also a 4-carbon molecule, malate. is also a 4-carbon molecule. And this enzyme known as fumarase will add water to this enzyme, to this reaction. This enzyme will add water to this reaction, and then this reaction is also irreversible. This reaction is also irreversible, so it is going to add water to this reaction. And this enzyme is a very important enzyme. This enzyme fumarase is a very important enzyme. A deficiency in this enzyme can lead to the formation of lyomas. Yes, deficiency in fumarase enzyme can lead to what we call lyomas. So lyomas, yes. And these lyomas are tumors that develop within the smooth muscles. They are tumors that develop within the smooth muscles, and they are very common in the uterine, smooth muscles, and in the kidneys. Yes, so a deficiency in fumarase enzyme can lead to these lyomas. And after we made the malate, an enzyme known as malate dehydrogenase. So let me write it. Malate dehydrogenase. This malate dehydrogenase will also come in and then convert this malate to an oxaloacetate. This enzyme malate dehydrogenase will convert malate to oxaloacetate, and when it does that, NAD plus is being converted to NADH. So NAD plus is converted to NADH. Yeah. And also, this is because we have a dehydrogenase enzyme, and this enzyme is also a reversible. This reaction is also a reversible reaction. Yes, it's a reversible reaction. And then from here, this oxaloacetate can also fuse with another acetyl-CoA and then form citrate. And then the cycle will continue and continue. So remember, we made 2 pyruvate molecules, so the cycle will be run twice because we made 2 pyruvate molecules from the glycolysis. And so in this Krebs cycle, we generated we generated 4 carbon dioxide, 6 NADH, 2 FADH2, and 2 ATPs. So these are the main products of this enzyme: 4 carbon dioxide molecules, 6 NADH, 2 FADH2s, and then 2 ATPs. Yeah. Thank you for watching. Please like this video, subscribe, and then press the notification bell to get notified whenever we upload a new video. See you in our next video. Thank you.